This is a VW Type 25 rear window aperture. Well, 80% of it to be accurate. The other 20% is currently missing in action and I don't think it's coming back, but I guess that's where I come in. To turn this 80% window aperture back to 100% window aperture is a tricky job, and I thought perhaps an interesting video. So what I'm going to do is I'm going to cover this in filler, give it a sand, give it a paint. It's going to look brand new. You don't want to do it that way? Fine, we'll do it properly. I've already removed the sliding door rail and the trim piece, and of course the glass. What is going to make this repair difficult is heat distortion. I removed the retaining screws for the inner trim and we can see inside. It's going to be necessary to gain access to the inside for rust protection later. The window section is only single skin. Keeping heat distortion here to an absolute minimum is important. Carrying out filler work in this area will be difficult because of the trim piece and body swage line. The sliding door rail was held with spot welds, and I can use these spot welds to make note of where it was. Window aperture measurements also need to be taken, as I will lose this dimension soon. I should be able to use the old window radius corners as templates for the new one. Here is the plan. I'm going to replace the section outlined by my finger. I've taken some basic measurements of all the fold locations and I'm going to make a test sample. I've marked all the fold locations using a set square from a single datum. The first fold is a swage, only a 1mm stepped section, and I've done this with my stepped rollers in the swaging tool. The next fold I realised I marked the wrong side, but I can transfer this to the back side quite easily. Folding all the sections with the fly press. We are good towards the front of the vehicle, but a slight alteration needs to be made at the back. It seems to taper slightly here. I'll make sure I allow for this when marking out. Time to cut out some material, and this means cutting into a new 8x4 sheet. Actually, it's metric, 2.5 meters by 1.25 meters, but it sure was easier to say 8x4. I appreciate my guillotine a lot when it comes to this sort of cutting, a tool I did without for a lot of years. My big folder is something I don't use much. It needs some attention in order to produce a tight radius. It's okay for folds that need a large radius, but anything tight it can't do at the moment. It will get sorted at some point. It was sadly abused in a past life. I'll go back to my fly press because the radius in the corner is still too big. A useful feature of the fly press is a stop nut. It allows you to produce consistent and repeatable bends. The last thing I need to do with this sheet is the swage. If I muck this up, I'll probably have to start over. A bit of care and attention needed then. To make sure this comes out straight, I'm pushing the material to the right so it slides along a stop. Following a line freehand won't be good enough unless you're somehow gifted that way. I'm really happy with that. I'm going to replace this rusted section after the panel has been welded in because I'm worried that any forming or welding could pull the swage down. It wouldn't take much to make a visible deflection in the swage. The panel is clamped to the vehicle in the right place and I can mark a cut line around the window aperture from the inside. I'm using my homemade angle grinder straight cutting tool here. It has tungsten carbide glued to the angle to prevent wear. I did a video on this for anybody who hasn't seen it. It cuts almost as good as the guillotine, but of course I can't use the guillotine in this situation. Part of the old panel is spot welded to the inner part of the van and there are more spot welds than first realised. Before committing to the welding, I just need to check the 400mm window height dimension. I also need to keep an eye on this edge as the welding might try and pull it over to the right slightly. I've used self-tapping screws to pull the panel towards the inner reinforcer. Recutting some sections is necessary to be able to properly align the panel. I get asked sometimes what settings do I use on my welder. The answer is setting 3 out of 6, but that's not helpful because every welder is different. The helpful answer is have it as high as you can without blowing a hole. You want to see the weld penetrate through even with just a tack from cold. Setting 3 of 6 on my welder would be too high for a stitch weld in this situation, but it's just right for a tack. Leaving the panel to cool between sets of tacks is always a must, but some grinding can sometimes be done in the meantime. Here is the best way to produce a uniform radius. Grind the edge like this. I made an adapter for my air cutoff tool to take standard 4.5-inch angle grinder discs. You can get a thick piece of metal inside the cavity as a dolly to smooth any welding distortion. After repairing this last section, the welding has created a low spot. I think that demonstrates how sensitive to welding distortion this panel is. Imagine cutting and welding all the way along here. It would be a nightmare. The right way to fix this welding distortion is stretch where the welding caused shrinkage. I can just about get a dolly of sorts to the inner weld. That has brought the distortion out to acceptable levels. Always check for pinholes where possible. The sliding door rail is a little rusty. Rest assured I won't be putting it back looking like this. An air descaler will just speed up the blasting process. The panel rail will also receive the same treatment. This panel retaining strip I think is best to plug weld in 2 stages. Let it cool, then go back and push the strip flat to the repair panel. The heat will lift it away on the first attempt, and that needs to be pushed back down again once cooled. Tricky plug welds these, so be careful here. To grind the plug welds, all I have to do it is a cutting disc, and I'm grinding it on the side of the disc. Not advisable, but with care it can be done. It is possible to use a spot weld drill to get most of the material off. The metal and welding inside, of course, will have to be protected. Paint then wax. I've primed the outside and sealed the overlap joints with Tiger Seal. This is one of the reasons it rusted so badly, because water got in between. I've just sprayed some 2K black on the panel because I'm only doing the metalwork on this van. I did manage to brush some paint on the inside. To speed up the curing, I've got an infrared heater and I'm using an infrared thermometer to check the panel temperature. With that cured, now I can spray some cavity wax inside. Putting the window back in on these is a bit of a pain, but I was told by someone to do it in a different way than the normal string method. What you do is put the seal on the vehicle and then insert the glass into the seal. I've started by having the glass in the lower seal and I'm prying the seal over the glass with a plastic trim tool, while keeping some inward pressure on the glass. Pushing the seal from the inside is working where the seal is tight. I think this method is easier than the traditional way and you can do it by yourself. Inserting the filler strip is easy with this special tool. That's it for this side, but unfortunately these Type 25 vans have 2 sides to them. It's hobby time for me now. Bye!